Okay. Number in 118, we're wanting to associate the whole number multiples of 8 with the natural number multiples of 5. Now you have to be careful, okay? Because the whole numbers and natural numbers aren't exactly the same. The whole numbers include 0. The natural numbers start at 1. Natural numbers are your counting numbers. You don't need 0 to count, but you complete the set of whole numbers by adding in 0 to the set, okay, to get the whole numbers. The whole numbers are 0, 1, 2, 3. Natural numbers are 1, 2, 3, 4. So when we write down the whole number multiples of 8, we got to start with 0 because the first whole number is 0. So we have 0, 8, 16, 24, and we understand that. And then the natural number multiples of 5, the first natural number is 1, so we start with 1 times 5, which is 5, and then 2 times 5 is 10, and so forth. Okay, so we can write these sets down like this and put some arrows in, and we've depicted a one-to-one correspondence between these two infinite sets because it's clear how this pattern continues. Now that isn't a computational rule, and to get full credit, you got to say, say something a little more explicit. For example, if they'd both been natural number multiples, then we'd have had 8, 16, 24, 5, 10, 15. So the nth member of this set, like the third member of this set, is 8 times 3 is 24. The third member here is 5 times 3, which is 15. So what we're going to do is we're going to take 8 times the number of the element in the set. In this set is going to be matched up with 5 times that element in this set, meaning that if, in the case I illustrated, n was 3, we look at the third member of this set, match it with the third member of this set, and the third member of this set is 8 times 3. The third member of this set is 5 times 3. Okay, well, let's see how it's going to work here. The first member of this set is 8 times 0. The first member of this set is 1 times 5. So the first member, you're going to use the number 1 here, but you got to use the number 0 here to calculate this member. Okay? Then here, the second member of each set, the second member of the top set is 8 times 1. The second member of the bottom set is 2 times 5. Okay? And then for the third member of the set, 8 times 2, 3 times 5. Okay, well, the number of the member of the set, if the counting number you use to find the number of the second set is easy. It's just the number you're going to use here. So I'm going to call that number n. So if we go to the nth number of this set, it's going to be n times 5. If we want the 738th number in this set, we're confident that if we multiply 738 by 5 and do it accurately, we'll be able to compute that number. What about the number over here? What's that number going to be? What's the nth member of this set? Well, we're going to multiply 8 by 1 less than the number of that member, so that the third member is 8 times 2. The second member was 8 times 1, and the first member was 8 times 0. So what do we conclude? We got to multiply 8 by n minus 1. So right there is a rule that associates this set with this set, and you could use that rule to calculate it. Okay, and I won't go into detail about that. If you can get down to this point, that's full credit. If you just draw the picture and draw the arrows in a way that actually works and can be extended in an obvious way, it's probably 7 points out of 10. And any decent attempt at this would be worth partial credit, even if you didn't get it all the way.